Okay, so now it's recording. Let me remind you guys that the exam is on December 16th. Okay. I will have office hour on Friday at 1:15 p.m. I will have office hour. I urge you guys to start solving problems if you have not already started solving problems from chapter 6, 7, and 8. And please bring your questions to the office hour. And I will be very happy to answer your questions. If you guys need, I'm also able to hold another office hour on Monday, but for now, I don't know if it's good to schedule that for now because I'm not sure. Maybe you guys, some of you might have exams starting from Monday, so I will not schedule it right now, but I will be happy to hear your feedback. If you guys want me to do it on Monday as well, I will do it.
Yes, please. Let's do it on Monday, Professor.
Okay, so if that's the case, then I'll have it, but then I will also record it so that others also can.
Will you have Fridays as well?
Friday for sure. I will have on Friday, and that's because I want you guys to start solving these problems because homeworks are very, very important for the exam. So start working these exercises from chapter 6, 7, 8. And then if you have any questions, please bring those questions to yourself. And I can also have a hour on Monday, as I said. But Friday for sure. Now, and it's, as I said, now it's scheduled for 1:15 p.m. The exam has 24 multiple choice questions. And 12 analytical. With sub-questions. So in this exam, you will be busy. But having done and understood put this here.
I have a question though. For
Yeah.
the exam, will it be like midterm 2 where if the question is wrong, it lets us redo the question rather than the whole test?
I think it will be more like the first one.
I still like don't get how it's like possible to get 12 analytical without having like the option to check each question and 24 multiple choice all in 2 hours. It ends up being a lot more than what we even had on the first one. And on the first one we ran out of time, so I feel like we're not even gonna have time to finish like 5 analytical, but let alone like even taking a
Let me
little bit.
answer to that question a little bit later, but for now, let me finish this sentence. So you will be doing well if you do all these homeworks from chapter 6, 7, 8, understand those homeworks. The homeworks from chapter 6, 7, and 8, you should be fine.
Professor, I don't think it's a matter of understanding it. I think that if you give us more time, we'll be able to actually finish it, right? Like we'll prepare and study from the homeworks of 6, 7, and 8, right, and do them. But if we don't have enough time to do the questions, then we can't get a good grade because we'll end up running out of time and get points taken off because of it.
Yes, guys, but I have done this before. So time yourselves when doing homeworks and try to do that like in a limited amount of time. You will not see questions that are different from like they will have different numbers, but they will be very similar to homework. So you have to know how to do those homeworks and you will do well. Because I mean, you have 2 hours and 25 multiple choice questions and 12 analytical. That means 25. The multiple choice questions are like, if you know, you know. If you don't know, that's 25 multiple questions is nothing. It's like 10 minutes, 15 minutes.
15, yeah.
Maximum 20 minutes. And then you have 1 hour, 40 minutes for these 12 analytical problems. And I know it can be done, right? So please, let's don't discuss this right now because I mean, I thought about this, and I think, and also remember that I card. So also remember.
Professor, sorry, I just misheard. One girl asked a question about will we have this function like check the your answer, right? Like in the second midterm. Will we have that feature or not? I just misheard.
No, because I mean that will give you guys the expressions then that you can use. Like it gives you a lot of hints. See?
Oh, it will give us hints.
Right? No,
it doesn't.
No, Professor. I don't. On exam, it would just say it's incorrect. Try again. It doesn't show like on a homework like formula or what to use.
is it not like because I set it up like the last?
It just says please try again. I can show you. I can
Yeah.
demonstrate it.
Because okay, let me say this, guys. Let me say this. The first midterm, I created is as a test. Pearson allows you to create a test or a homework. The first one I created as a test and gave you guys 2 attempts, but that was bad because I mean until you did all of the tests, you would not get the chance to redo, right? So the second attempt was kind of pointless. Having realized that, I thought maybe I can give a test, but set it up like a homework. And that's what I did. But the thing is, when you do homeworks, then you get help, which is like gives you the formulas that you will be using, like you do the homeworks, right?
Yeah.
But
But the second midterm did not have the same features as the homework did. Like the hint, for example, we did not have that.
I have to make sure.
I mean, not the hint, not the hint, but like, help to solve this problem. We didn't have this feature.
Really? Okay, so I thought.
Yeah, we
Because
just had to try again.
Okay, let's guys talk about this later because I did
Okay.
set it up like a homework, right? So that's the only concern I have. Like, if it works like a homework, then that's a problem because I mean, what's the point of the exam,
Yeah,
right? So I cannot really accommodate that.
yeah.
So please understand. And so I have to make sure that it's not like the homework, but you still get 2 attempts, right? So right now, I am not sure, right?
Okay.
So also, please remember that I card. So which means that thus, please work hard and try to show best of your knowledge.
Wait, when you say curve, do you mean like curve the entire course grade or curve like the exam grade?
I carve entire course grade.
Oh, okay.
So please don't stress a lot, and try to concentrate on, I'm giving you only, I mean, the exam is only about 3 chapters. So that's possible. So please don't stress, just try to show the best of your knowledge and remember that I carve. Okay, now let's, for example, today I solved certain problems in the office hour, and one of them I did in Excel. It is like very quick. So if you guys, sometimes, I mean, it is easier to do stuff in Excel. Okay, now let me do some problems from chapter 7. I will do problem number 7.4 because that's where we stopped last time. Or did I do this as well? Do you guys remember if I did this one?
Which one?
7.4, do you see?
Yeah, no, last class at the very end, the last thing that you left us with is that this class you will be doing 7.4 and 7.5.
Okay, let me do then 7.4. So what do we have here? This is about the table above. And the question is, do there appear to be regional differences? Use an appropriate hypothesis to explain your answer. Okay, that's about locational. When I say regional, that's like kind of confusing sometimes because people may understand it like original because of my pronunciation. So I will say locational. So how many locational dummies do we have in the model? We have 1, 2, 3. And the last one, west, is omitted because if we included it in the model, then we would have a problem which is known by dummy variable trap. Dummy variable trap means when we have perfect correlation between the independent variables. So these are the locational dummies, guys. So this is northeast. If you see, first of all, do you guys hear me well?
Yeah.
Or at least can you understand what I'm saying?
Yes.
Yes.
Okay. Northeast, that is variable 4, x4, right? That will correspond to which coefficient? Very simple, guys, please. Say beta 4, right? Beta 4. Then we have x5, guys. That will correspond to beta 5, right? And then we have x6 because that's variable, dummy variable south. And that will correspond to beta 6. Okay, these are here in this column, these estimated values, right? So the estimated parameters and also their corresponding estimated standard deviations, guys. So when they are asking if there is locational or regional differences, then we the appropriate hypothesis here will be are these parameters jointly significant. So H now will be what, guys? Beta 4 equals 0 and beta 5, comma stands for, and remember, beta 5 is equal to 0, beta 6 equals to 0. Guys, please listen carefully. And H alternative will be what? That beta 4 is not equal to 0 or and because both of them are possible. Beta 5 is not equal to 0, or and beta 6 is not equal to 0. So guys, what I want to say is that please never write hex in the hypothesis, because that will show that you don't really understand a lot of econometrics. So always, hypothesis is always true parameters, right? So these are true parameters, right? And you are testing hypotheses about the true parameters because we don't know the value of those. And how do we test? We are using sample stats, sample statistics, right? Beta 4 head, beta 5 head, beta 6 head. That's something I'm sure you guys know, but I just remind you. How can we test this hypothesis, guys? Can you help me? Please be involved in class if you can. This is a joint test, right? Test of joint hypothesis, right? How do we test it? So we will have the restricted model, we will have restricted model, right? Okay, what will be our restricted model, guys? First, okay, what will be unrestricted model? Guys, are you here? Will be column 3, right?
Yes.
What will be our restricted model?
Column 2.
Why?
Because we're restricting 4, 5, and 6. And if you're restricting 4, 5, and 6, it would essentially have a blank mark on the table.
That's absolutely right. But why? I mean, first column also has blank cells for beta 4, beta 5, beta 6.
That's because our null hypothesis
Is not about beta 3, right? So
yeah.
so there should be no blank cell for beta 3 in column 1, right? If it is the restricted model. Do you understand? So the restricted model, therefore, is column 2. Thanks a lot, guys. So you did it. So now we know what are our restricted and unrestricted. So therefore, we'll take R squared unrestricted from the unrestricted model, which is what? Can you guys please help? Because that will make our pace. We will proceed at a smoother pace if you help.
0.185.
And then we need to pick up the restricted R squared.
0.182.
Okay. Up until now, are we guys doing well?
Yes.
In the formula, we need number of restrictions Q, which is what in our case?
3.
3.
What is number of, okay, what is K, guys? Can you remind me?
Number of independent variables.
variables.
Unrestricted model.
Very good. So how many independent variables do we have in the unrestricted model?
6.
That's absolutely right, because this is 1, 2, 3, 4, 5, and 6. But this one stands for the intercept. That's not independent variable. That's just an intercept. Are we now ready to use the formula for the F stat? No, because we are missing what? Number of observations, right? Which is what? This is the same as same in both restricted and unrestricted models, guys. So you don't have to worry about from which model to pick the number of observations, right? Guys, am I clear?
Yes.
Now we will just plug in the numbers because we remember. I mean, if you don't remember, I remember because I did this so many times. Finally, I remember, and even sometimes I make a mistake. So, but you will have the. I mean, the exam is open book. You can take notes before the exam. Write down the formulas that will be useful for the exam, and it will be fine. So we know that f stat. In this case, we will be using f stat based on r squareds, right? Not based on SSR because we don't have SSRs here. Do you guys agree with me?
Yes.
Sorry, I think the formula is what? Do you guys remember? R squared restricted minus R squared unrestricted, right? Because I forgot. I think. What is it?
Unrestricted minus.
It is R restricted. You're right. You're right. So minus R squared restricted, then divided by 1 minus R squared,
Unrestricted.
and then n minus k minus 1, right? Okay, so it looks like I have different numbers. They have changed the numbers. So they have changed the numbers. I don't know why, but they have. So then we will have what? So this is easy because this is 3. We have all these values, right? So because, okay, this is 0.185 minus 0.182, and then 1 minus 0.185, and then n is 7178 minus 6 minus 1. Do you guys agree with this? And then we will calculate a number which unfortunately I don't have. I have a different number because the numbers for R squares are different in this. So they have probably changed than the values. But it's okay. No. I don't know why. Okay. So let's say it is. Do I have to calculate? So this kind of calculation is very easy to be done in. You can do it in your calculators as well. Let's say, guys, I don't have the number for this, but let's say it is. Don't make me calculate it because we lose a lot of time. Say if stat is 3.85, let's say, right? And then what is the next step? You need to pick F critical, right? At 5%. It says at 1%. See? They say 7.4. Say one to test the hypothesis. There's no 1%. Okay, let's do it in 1% because 1% is like, they don't specify at what is the significance. Do you guys see if they don't specify the significance level, right? Okay, so let's say what is let's see what is F critical at 1% significance level. For that, we need to know what the number of observations here is a lot, right? So number of observation n is 7178. That is much greater than 120. So we will not be using the first. We will be using we will use the first page of F table. Let me now open F table for you guys. F distribution table, that's it. Now let me share the screen because So this is the F table, guys. And this is the first page. This is for, the first page is for a situation when the number of observations is greater than 120, so that it is treated as infinity. So, and then we are looking at the significance level and also the number of restrictions. In our case, number of restrictions is 3, guys. So we are in this row, right? And depends on the significance level, right? So we will have 3 values, right? So, but if we are testing the hypothesis at 5% significance level, for example, then the critical value will be 260. Do you guys agree with me? If we are testing the hypothesis at 1% significance level, then the significance level will, the critical value will be 378. Okay, guys? Let's test the hypothesis at let's say 1% significance level. So let's see. Share the screen once again. Okay, you still don't see both. Let's say if statistic is, let's say, bigger, because it will confuse you guys. If it is, let's say, 6.85.
I did calculation. Is it possible to get 10 for FStat?
Yeah, it is possible even to get 1,000.
Okay, for this particular one, I got 10.
Thank you very much. So then, perfect. So 10.00 or what?
Yeah, 10.00.
Okay, good. So that's fine. 10 is 10. So, and then remember the F critical from the table was what? Was 3.78, right? That's from table 3.78. This is at 1% significance level. So what do we do? Then compare 10 to 3.78. 10 is greater than the critical value. So what do we do? Do we reject H null or do we fail to reject H null? F stat, which is 10, is greater than 3.78, which is F critical at 1%, right? So therefore, we reject H null. So then what is our conclusion? That at least one of those coefficients are different from 0, right? So at least one of those 3 betas is different from 0 in statistical sense. Do you guys agree with me?
Yes.
So this means
Yes.
that this, thank you. This means that yes, locational dummies are there, are important, and therefore there are locational differences. Now let's do part B of this question. Juanita is 20. Do you guys, is this really small? Because if I increase the size, then it might be too much.
No, we can see.
Right.
Is it possible to zoom in on the homework?
The homework. How about now, guys?
There is a little tip, guys. If you don't see too well, just go on top on view options, and in zoom ratio, instead of fit to window, just put to original size, because professor's screen is larger than ours, and then you will see really large.
Okay, yes. So, but do you guys see this part?
Yes.
Good.
Yes.
So Juanita is a 28-year-old female college graduate from the South. Molly is 28-year-old female college graduate from West. So guys, the only difference between Juanita and Molly is that they are from different regions, but they otherwise are similar, right? Same, right? So they are both have the same age, both are female, both are college graduates. So do you see what I mean? So the only difference between these ladies is that they are from different locations, right? And Jennifer is a 28-year-old female college graduate from Midwest. Same. So so all of these ladies are have the same characteristics. Simply, they are from different locations or regions. Construct 95% confidence interval for the difference in expected earnings between Juanita and Molly. What would you do? I just hinted you guys how to solve this problem. For which, can you guys hear me? For which coefficient would you construct 95% confidence interval? Can you help?
Age.
No? Think about it, please. They have the same age. They are both
direction.
female.
South and west.
Exactly. That's exactly right. But do you have both in the model? West is omitted from the model, right? So everything because of that is relative to West. So if you just test the hypothesis about the coefficient in front of South, that will be the answer to this question. And then construct 95% confidence interval for the coefficient which is in front of South. So let's look at the table, guys. And we see that the coefficient here is in front of South is minus 0.44, right? And then I think this is part B of this question, right? Oh. Part B of this question. So we will construct 95% confidence interval for this coefficient, beta 6. So that will be minus 0.44 plus or minus 1.96. Because the sample size is really large, you can take this number as the critical value times what, guys? The estimated standard deviation of beta hat 6, which is given 0.37, and that will give you two numbers, right? So you will have some number, and also you will have another number. I have different numbers because it looks like they have changed numbers. But you get the point, guys, right? Please tell me if you don't.
Yes.
Okay, good. The last question here is, Sally is a 29-year-old female college graduate. Betsy is 34-year-old female college graduate. Construct 95% confidence interval for the expected difference between their earnings. How would you do that? Can you please help me? So these ladies are again have the same characteristics, but the only difference is in what, guys? In age. In age. Very good. Now, what would you do is that you would construct 95% confidence interval for which coefficient? Which stands in front of the variable age. Do you guys agree with me?
Yes.
So that is here, 0.61, right? So then this is part, that was part B I think this was part B.
No, of 7.3. No. The one that you just did is part B of 7.3, and the one above is of 7.4.
What?
Yeah, weren't you doing something with the West and Midwest?
So where is, did I miss anything, guys?
No. You just finished problem 7.4, and then you did B of 7.3.
That's because I probably, lost myself. 7.3 we did before.
Yeah, we did that already.
Yeah, so which one did, so we did part A here.
You didn't do 7.4B part 2.
Yeah, now I am doing it. Yes. Okay, so yeah. Now I will do this. But you know how to do this, right? Let me do it for, let me remind you guys. Let me remind you because maybe that's good. And then I will do 7.4. Okay. 7.3 B2, right? So that's, I said confidence interval for the variable age. It was 0. And then remember the difference between ages is 34 minus 29, whatever it is, right? 0.61, where is it? 0. That's age, right? 0.61 plus or minus 1.96 times what, guys?
0.05?
Yes. And then you multiply this by what, guys? And
The difference in age.
That will be the answer to that. But now let me do part. I lost myself, but now thank you. I think I'm doing fine right now because now the only one part that we have left is this, right? Explain how would you construct a 95% confidence interval for difference in expected earnings between Juanita and Jennifer. So Juanita and Jennifer. Jennifer is, guys, so Juanita lives where? Juanita lives in South, Jennifer lives in Midwest, right? But both of them are parts of the model, right? Do you see what I mean?
Are you saying both South and Midwest are part of the model?
Yeah, because West is the dummy variable that is omitted. If you take a look at the table, you see that Midwest and South both are a part of the model, right? Do you see that?
Yeah.
Okay. So what do you think would be the easiest way to construct 95% confidence interval for the difference in the dependent variable between these two ladies? Juanita, who lives in Midwest, right? Juanita lives who lives in someone who lives in Midwest and someone else who lives in South. Otherwise, they have the same characteristics. Think about this for a minute and let me know.
Do you do the difference between the South and Midwest?
Difference between South and Midwest, that's exactly right. That is one possibility, but then you will have to know the standard deviations, right? But you can compute that, right? So because you have standard deviations for beta 5 hat, which is 0.40, guys. And you also have the estimated standard deviation for beta 6 hat, which is 0.38. So then you can calculate the difference between the estimated standard deviation of the difference between the two estimated coefficients, right? You don't have to do any calculations here. Just say this, whatever I said. It can be done, like you can take a look at the coefficients, and you can just construct confidence interval for the difference in the estimated, for the difference in coefficients is using this coefficient here, 0.74, and using this coefficient here, minus 1.54. And you will be constructing confidence interval for what? Beta 4 minus beta 5, right? Beta 4 minus beta 5 using beta 4 hat, which is 0.74, and beta 5 hat, which is minus 1.54, and their corresponding estimated standard deviations. You don't have to do any calculations here, but that's what they simply ask you, how would you do it? We will do a very similar problem, which is 7.5, which is actually asking us to do something similar, something very similar. So let's take a look at the problem 7.5 right now. So we have this estimated model, guys, here, and but this is what? This is the same regression as in table that we had. Let me see. The regression shown in column 2 was estimated again for a different year. So see this? Column 2 does not have this locational damage, right? So that's the regression in column 2, right? And the same, this is for which year? So do we know this? This is for 2015, right? It says 2015, that's for 2015. And then they estimated the regression for 1992. They estimated the regression for 1992, and the results are here. And the question is, comparing these, I think that's the last problem I will do today, and then I will let you ask any questions that you may have, because I think then I'll have solved all of the problems that I wanted to solve. And then I will let you ask questions, and then I will also have office hour on Friday. Okay, guys, now we have two estimated models. One is estimated for 2015 and the other is estimated for 1992. These models have the same dependent and independent variables. Up until now, guys, am I clear?
Yes.
Thank you. So now they're asking us, is there difference in statistical sense? So meaning, is there statistically significant difference between the coefficient in front of college during these 2 years, right? So we have a model that was estimated in 2015, and this model also was re-estimated for 1992. And they're asking us, okay, there's a variable college, and that has a coefficient, right? In this case, college is the first variable here, right? So, but let me call this beta college, the coefficient. This beta college, that is part of the model in 1992 and in 2015. But we have two different models. So therefore we have beta college for 2015, and also we have beta college in 1992. Now they're asking, is there a difference between these two coefficients? So they're asking us what, guys? To test the following hypothesis, that beta college 2015 minus beta college 1992 equals 0. That will be our null hypothesis, that there's no difference. And if you reject it, then there is a difference, right? Alternative will be Z. If I wanted to test, like, is there a positive difference? Then you would say that the greater than 0, less than 0, right? But I'm not doing it right now. Okay, how do you do this? What would be test statistic, guys? Would be
The difference between the 2 years for so Beta College of 2015 minus Beta College of 1992.
but you meant heads, right?
Yeah.
Minus 0, right? Because that's the hypothesized value, remember? Here, 0 is the hypothesized value. And then you divide it by what? Sigma hat of
2015
no.
plus, would you, oh, never mind.
On this. This is just a subscript. Okay, so now we have to, we have these numbers. So we have Z, right? We also have this. What is beta head college 1992, guys? This, right? 8.94. Do you guys agree? And beta head 2015 college will be from the table above. So, but for this, we need to calculate first the variance, right? So, but we have to, we assume, like you have to assume, otherwise you won't have these covariance terms. So there's no correlation between beta head 2015 college and beta head 1992 college. So, okay, then the first, you need to calculate variance of beta head 2015 college. This is 15 minus beta head 1992 college. And this is because there's no covariance between these two heads, then you will have variance of beta head 2015 college plus variance of beta head 1992 college. Good. Now do we know this, guys? Or do we know this? Guys, please help me. Are you here? So what will be this? Do we know that? Look at this regression estimation, the estimated one.
Yes. Oh, do
No, it's
no, we
standard
don't. We
deviation.
don't.
This is
Wouldn't it be 0?
What?
Yeah.
No, squared, right? You mean that's the standard deviation, the variance of this standard deviation squared. But do we know this? Yeah, because it's in the table, right? In column 2. Here, 0 point, this one, guys. And you get the number there, which is, oh my God, they have changed number.
Wait, Professor, I think for 1992, I thought the standard error was 0.34.
Really, let me see. Do I have an extra? Yeah, true. It's just 0.34, not that. Guys, can you please calculate this for me, because then I have to open Excel, and can you give me the number here? Because it looks like they have changed numbers. I have different numbers, so
I got 0.1997.
But then you have to take square root of it, because that's the variance of the difference, right? So then sigma hat of the difference in beta heads that will be what? Take square root of it, please.
0.4469.
Thank you very much. So now we have this. Now we are ready to calculate this test statistic, guys, which is what was it, 0.44? Can you please repeat?
0.4469.
69. And then we know that this beta head 1992 college is what? 8.94. And then we are missing this beta head 2015 college, which is 10 point, that's here, 10.44. Can you guys calculate this for me? And the answer is
3.356.
thank you. Okay, good. So what is the critical value at 5% significance level?
1.96.
You are right, because the sample size is like pretty large. If not, then if it is less than 120, then it would be using this T table, right, to pick the right critical value. So okay, so then 3.356 is greater than this, right? 1.96. So what do you conclude?
Reject no hypothesis.
That's good, but what does it mean? Set the difference between the coefficients of college in these 2 years is not zero in statistical sense. Do you see what I mean? Because we rejected H now, guys. So we rejected that. What was our hypothesis, guys? Yeah, so we rejected that we have this at 5%. So that means we don't have that, right? So there's a difference, different from zero, between the coefficient in front of college during these 2 years. That's all, guys. That is the last exercise I wanted to solve today. It looks like I did finish it too early today, but I allow you guys to ask any questions that you may have. So this is the end of the class. Let me, yes, please go ahead.
Yeah, Professor, I was just confused regarding the final a little bit. I just wanted to clarify and make everything solid. So the final will follow the second midterm format, where we'll just have like a quick check where it would show if the answer is wrong or not, or would
Yeah,
be
so
like that?
that's so guys, I need to make sure that when you do this exam, you don't get like the formulas and expressions like
we
you
don't have
do.
to
Right,
solve
like in the
this
second
problem.
midterm.
Yeah. No, in the second midterm,
Yeah,
did
we
you?
didn't get it exactly. So that's what I was making sure. Like, would it be the exact same format as second midterm, where once we click the check button?
Can you please tell me the difference between first and second midterms?
So in the first midterm, what the you said we'll have two chances where we will be able to check our answers.
Mhm.
So we had to, if we got an answer wrong, we would have to redo the entire exam instead of just that one question. But in the second midterm, it was different. It was similar to the homework, where we could check a particular question, and it will tell us if it's wrong or not. It wouldn't give us any formulas or anything. It would just tell us if it's wrong or not, and then we could redo it on the spot instead of just doing like the entire midterm over.
So it doesn't give you hints how to.
No, not
No,
at
it does
all.
not. It does not do help me solve this. It does not have that feature.
Okay.
Also for homework, since we had unlimited, it was just like constant try again.
Yeah.
Exam once, so like I got something wrong, and before, so we submitted part by part. On first one,
Then it looks like, guys, you really like you did outstandingly. That means you really understood everything, which is like very good thing. So if you
the
don't,
only notification it gave us was like your instructor has limited number of attempts to 2, so this is your second and last try, and that was it.
I think
But-
the reason why we did better also was simply because of the time. It wasn't because of like the format of the exam. It was just the time was better, so that's why we did.
Also, just to add on, I was concerned about this because you know how Pearson sometimes the way you round it, it's like mistakes everything. So that was like my primary concern. Like a simple decimal mistake would make the entire question wrong and take off a lot of points.
okay, guys, I trust you. So that I trust you that you say that you don't get any help. Like,
I mean, we could try. You could give us like one exercise, for example, and we could like send you a screenshot or something that it doesn't have the features. We could check.
no, I trust you because you say like not. Everybody agrees with that, right? Or
Yeah.
Yeah, we agree, Professor.
We understand that we have the time constraint and you cannot do anything about it. But if we had this like the second midterm, try. See if the question is wrong. That would be very helpful.
okay. So then I will do it like the second midterm. So don't worry.
Thank you so much.
Okay, I'll do. The only concern, the only concern I had was that if you are getting hints how to do the problem, then there's no point in having the exam. So because the exam you should know how to do it.
Yeah, if you want to like just to like make sure that there's nothing like mistaken, you could just, like someone said, give us like an example where we could just quickly check if it doesn't give any. The second midterm definitely didn't give any hints.
Okay, thank you very much. No, there's no need to do that. I understand, and I will do it like I had the second midterm. So that the only thing that is different is, as I understand, that you have a second try per question, not per the entire exam. And if that's the only difference, I'm fine with that.
Thank you so much, Professor.
Okay, guys. So, do you have any other questions? Remember.
Question about the problem that we did that's up on screen now. It's just like, so I understand how, but I don't understand why. The restricted, how is third column unrestricted if we have this Northeast, Midwest, and South? Aren't those restrictions? So why do we call it unrestricted?
No, the restrictions are that the coefficients are 0. So you are not allowing coefficients to take any value. You are restricting them to be 0, to have some particular value, in this case 0. So see, in this case, we had only, we were talking about beta 4, beta 5, and beta 6. We don't allow them to take any values. We just hypothesize that they are 0, right? So see, let me go up. Do you see my blue screen?
Yes.
So here, I am not allowing beta 4, beta 5, and beta 6 to take any values. I am restricting them to take only zeros. Because of that, the restricted model will not have these beta 4, beta 5, beta 6 because they are 0, right? They will not have terms that include beta 4, beta 5, beta 6 because they are beta 4, beta 5, beta 6, they are 0. But the unrestricted model should include terms with beta 4, beta 5, beta 6 because the unrestricted model means that I have not imposed any restrictions, right? That's how it is.
Oh, and we choose second column because we want to allow for age to change.
Yes, because I am not restricting beta 3, right? So am I restricting beta 3? No, I'm not.
Okay, now it makes more sense. Thank you.
Okay. So what else, guys? Do you have any other questions? And also remember that please work on the homeworks. And on Friday at 1:15, if you can stop by, I mean, not stop by, join the office hour over Zoom. The link is already on the CUNY Blackboard. And I also send the link to you guys through Zoom, through CUNY First. And so feel free to bring your questions, right? And I may also have office hour on Monday if there is like, if you want. And you can also work on the problems over the weekend. And if you have questions, you can also ask me on Monday. But I have not yet set up the office hour for Monday. I did set up the office hour for Friday, though. Yeah. Okay. Okay, guys, I think I will then, if you don't have any questions, I will finish today's class, which is our last class. We don't have any more classes. The semester is over. First, thank you for choosing my session, and I hope that you learned some econometrics. This is just an introduction, but it is good to have solid introduction. Econometrics is something that you will need in your lives, and I recommend you guys to take as many econometrics as you can. I'm not sure in the future, but I'm also teaching the Master's Econometrics this next semester. But I'm not sure how I'll be teaching in the future. But I mean, anyways, doesn't matter who teaches. Econometrics is anyways very useful. So I wish you guys good luck in all of your exams. And if you have any questions, please email me or whatever. I also have office hours, and if needed, I can arrange another office hour on Monday. Thank you very much, guys.
Thank you so much, Professor, for everything.
Have a great weekend.
Thank you, Professor, for the semester.
Thank you for the class, Professor.
Thank you, Professor.
Yeah.
Have a great evening.
Thank you very much, guys. I wish you all the best.
Thanks, Professor. Have a good one.